Today we're diving into a really provocative idea. What if the biggest thing holding back scientific progress isn't the answers we can't find, but the questions we're not asking anymore?
So, let's start with a huge one, a question you've probably seen floating around. Is physics broken? Is our whole understanding of how the universe works just fundamentally wrong? It's a pretty dramatic thought, and it definitely grabs your attention.
But here's the twist. The answer to that question is a pretty firm no. Physics is not broken. And actually, if we think it is, we might be missing the entire point of what science is all about.
See, science isn't some dusty old textbook that's already finished. It's this living, breathing process. The whole goal is to constantly test ideas, to throw out what doesn't work, to add new stuff, and to just keep getting better. It's a system that's literally designed to be improved and corrected.
So, if the system itself isn't the problem, then what is? Well, it looks like there's a much more subtle danger at play here. It's not about getting the answers wrong, it's about not even asking the questions in the first place.
And that's where the real danger lies, in the questions we ignore. What happens when these really fundamental, really hard questions just get pushed to the side? When we all just kind of decide that, hey, this idea is settled, no need to look at it anymore.
And this is absolutely crucial. Ignoring a question goes against the entire spirit of science. The scientific method is built on curiosity. It's about listening, about reasoning, about rephrasing, but the one thing it's never about is just ignoring a good question.
Okay, so what kinds of questions are we talking about? Let's start with the absolute basics. The very building blocks we use to construct our picture of the world.
For instance, infinity. We talk about it all the time in math, in physics. But is it a real thing that exists out there in the universe? Or is it just a handy concept? You might be surprised to hear that scientists are still debating how to even properly define infinity. The ground under our feet here is way shakier than you'd think. Or how about this one? What is a number? Seriously, we use them every second of every day. They are the language of science. But if you really push a mathematician on it, there isn't one single agreed-upon definition of what a number actually is. It's one of those things that seems super simple until you look at it too hard.
And then there's continuity. Do we really know what it means for something to be continuous? Because this question, this one little question, blows open one of the deepest divides in how we think about the fabric of reality itself.
It really comes down to this huge debate. Is the universe fundamentally smooth, like a perfect ramp where you can stop at any possible point? Or is it more like a giant staircase built from these teeny-tiny individual steps? Is nature continuous, or is it discrete? We often just assume we know the answer, but it's still a massive open question.
And that leads to this other puzzle. When we're doing precise, exact math with numbers, does that automatically force us into that stepped view of the world? Is it possible that the tool we're using to measure reality is actually shaping what we see?
Okay, let's shift gears a little bit. We've talked about the building blocks of reality. Now let's talk about the rules of the game, the process of science, and how we even figure out what's true.
Here's a big one that gets right to the heart of what physics should even be trying to do. Is the goal to find these abstract laws that the universe just seems to follow? Or is it to build a complete mechanical explanation for how things actually work based on their properties? To put it another way, are we supposed to be finding the cosmic rulebook or taking the engine apart piece by piece to see how it runs?
All of this brings us to a fascinating, kind of meta question. We say things like mainstream science all the time, but how does an idea actually get that status? It's definitely not as simple as just being right. There's this whole journey an idea has to go on.
Well, one way to look at it is as a four-step journey. First, a theory has to be able to describe what's happening. Then, it has to be able to explain why. From that explanation, we get a real, deep understanding. And it's only after all of that that an idea finally earns our trust and becomes mainstream. It's a long road from just seeing something to actually believing in it.
So, we've looked at these massive, foundational questions, from the nature of a simple number all the way to the nature of truth itself. So what's the big takeaway here? It all boils down to one really powerful idea.
Think about the questions we just touched on. What is a number? Is the universe smooth or chunky? How do we even trust a scientific idea? These aren't just fun trivia questions. They're potential cracks in the very foundation of everything we think we know for sure. It's a pretty good reminder that there's always more to question.
Because in the end, you don't measure how healthy science is by how many answers we have.
You measure it by how brave our questions are. Real progress doesn't happen when we think we've got everything figured out. It happens when we have the courage to say, you know what, I'm not so sure about that, and then we dive in.
And that really leaves us with one final thought, which is more of a challenge to you. We've talked about some of the big questions science might have forgotten to ask. So, what's your question? What's the one big assumption you see out there that you're ready to start questioning?